So observe very carefully. So there is a spring balance. Just imagine like a spring balance. Okay. So there is a spring attached instead of string. There is a spring and the pulley is attached to the spring. And one side there is a mass 2 kg and another side the string whose mass is 4 kg. How much is the mass? All of you? 4 kg. And the spring constant. This is like a spring balance. So what is the use of spring balance, everybody? Spring balance is to measure the what? Weight of the okay. Just remember weight mission it is like a weight mission. So we all knows that. Let me consider the spring constant. K is equals to 100 Newton per meter. Okay. Now what is the elongation of string? That is what is my question. So elongation of spring, not string. Clear everybody? Elongation of what? Spring we have to find it. Okay. Wow. So now how to solve this one? So we have to consider what? Spring is considered as a what? Everybody. Spring is considered as a what? String. That's all. So then we all knows that, Mr. Rudresha, you might remember last classes. If here is the T means, then here is also a T means. Then what about the here?
2T.
Do you all remember that? What is the tension acting?
2T.
2T. Ellame remember the same principle we are going to use it here. So if it is coming like this, so observe. So we all knows that here 2 kg mass is acting. So 2 and here, sorry, it is coming down. So 4 kg. So it is 4. So notice it here. It is the same string. So that the tension is in the spring is what? This both are same string. So tension is same. Here also tension is same. But here, what is the tension in this? Here is the T. Here is the T. And here also T. Then here, what is the tension? Fastly. 2T. So 2T is equal to spring force. Am I right or wrong, everyone? Will you all agree with me or not? Yes. All of you. Now, as the body mass is more, acceleration is downwards. Here, body mass is less, acceleration is upward. Then here, weight is equals to mg. So m is equals to what? 2. So 2g. Here, weight is equals to mg. M is equals to 4g. Is it okay, everybody? Yes. Then FBDs. FBDs tell me, you should tell me FBDs for 2 kg. So 2 kg, if I draw FBDs, so what will happen? So upward force is tension, downward force is 2g. So acceleration is upward only. So this is positive and this is negative. So what is the first equation? T minus 2g is equals to F net is equals to MA. Respond everybody. F net is equals to MA. So that what will happen?
2A.
Okay, that is equation number 1. Next, second equation. A free body diagram draw. Free body diagram 4 kg. So 4 kg upward is T, downward is 4g. Now acceleration is downward. So that this is positive and this is negative. So what will happen? 4g minus T is equals to 4a. Am I right or wrong, everybody? All of you?
Yes.
That's all. So then add both the equations. So 4g minus T is equals to 4a. T minus 2g is equals to 2a. So add both the equations. What will happen? T will get cancelled. 4g minus 2g is equals to 2g. 2g is equals to 6a. Then 2 ones are 2 threes are. So a is equals to what is the acceleration? Again, a acceleration is equals to fastly.
G by 3.
G by 3. Okay. Now we want to find tension because we all knows that 2T is equals to what? Fastly. 2T is equals to spring force. Am I right or wrong? All of you? Yes, please. Because we want to find the spring force. So that, sorry, this elongation. So elongation means what we have to find? Delta x. Elongation means what? Delta x. Okay. So that is what. So now 2T we want to find tension. So one equation you can substitute it. So I will substitute in the first equation. T minus 2g is equals to 2a. Then T minus 2g is equals to 2 into a value g by 3. So now 2g will come this side. T is equals to 2g by 3 plus 2g. So what is the answer? All of you? 3 it is. So 3 2s are 6. So T is equals to 8g by 3. Okay. So 8g by 3. That is the tension. But we all knows that spring force. So spring force is equals to what? Spring force is equals to K into delta X. And we all knows that
Delta.
force is equals to 2T. 2 times of tension. So that's all. You can substitute it. So I'll write it K delta X. You can write it here. We know. So we know. So K delta X is equals to 2 into T value. How much? Fastly. T value
8G by 3.
3. Okay? 8G by 3. So means in the sense of, so delta X elongation is equals to how much it will come? 2 8 ja 16G
16 by
divided by 3K. That's all it is. That is the elongation of the spring. Is it okay, everyone? Clear? All of you? Now, if suppose if you want to find how much FSP, that is what spring force, then directly you can substitute here. Spring force is equals to, that is the value. So we all knows that, as I have given that constant value 100 Newton per meter. So we all knows that spring force is equals to 2 into 8G by how much is the answer? 3. So over. So 16 into G value. So G value is how much? Fastly, everybody. G value we can consider as a 10 or 9.8, which is equal divided by 3. So if we solve it, how much it will come? All of you.
Sir,
FSP is
by
equals.
300.
Yes, Rudreswar?
Sir, 3K, sir. 300.
No, I am saying FSP. FSP is equals to 2T, correct? Directly if you can find it. Clear?
Okay, sir.
Yeah, I'm not asking delta elongation. Clear? If they ask elongation,
Yes,
what is
sir.
the formula? 16 into 10 divided by 3 into K value, how much? 100 they have given. So you can solve it. So it cancel. So which is equals to 1.6 divided by 3. If you solve it, that is the elongation. Clear, everybody? 1.6 divided by 3
Yes, sir.
meters. That is the elongation. Is it okay, all of you? Understanding?
Yes, sir.
So if they'll ask you what is the spring force, then this is the answer. So 160 divided by 3, which is equals to how much? So that is what you can make it. So 160 divided by 3 newtons.
53.3.
Yeah. 60. Aswita, how much?
53.3.
53.3 newtons. That is what the spring force. Is it okay, everyone? All of you? And if they ask you elongation, as they are asking the value elongation, so G value you can take 9.8 or 10, so that you will get 1.6 by 3. So that is the elongation of the spring. Is it okay, everyone? Clear?
Yes, sir.
So that is how you have to consider. So what you have to do it, you have to consider the spring is like a what? String. And you have to go with the calculation. Clear, everybody? Yes. So that is what.
Yes, sir.
Finish it. So this is what one of the most important, like a spring balance. So how much it will stretch, the elongation of the spring. That is what you have to remember it. Okay. So now solve this question. If you solve this question, then one more question I will teach you. So that is even very important and very interesting also. The similar type of questions we will solve. Definitely NEET and JEE mains. Definitely there is a question related to the spring and as well as string. So have you all understand this question? Do you all able to solve it or not? All of you?
Yes, sir.
Okay. Yes. So please solve it. Once it is completed, let me know. Take your time, no issues. Shall we go to the next question?
Yes, sir.
Okay. So the next question, you will be experiencing the new things. So this is what I said, very interesting. Then if you solve plenty of questions, you'll explain it. You will like it will drag your attention. Even when I'm practicing for your purpose. So first two questions, I'll feel little like normal. Then after that, I feel more and more interesting to solve it. You all will experience the same thing. So there is a spring. There is a spring. So some mass is attached to that. And there is a string. Spring after what is coming? Spring, and the mass is 2m. So now basically generally you tell me, we used to play a game also. So there is a person who tied, the eyes are tied with a cloth, and he is hanging something in his, like a plate is with something, and there are two water bottles are hanging. You notice it, YouTube shorts and all, you might be watching. Suddenly, if you cut this this weight, this plate will go and will hit to his face. Do you all remember that? All of you?
Yes, sir.
Yeah. So the same thing here. For example, unfortunately, if I cut this string, then what will happen? This mass will do the oscillations. Am I right or wrong, everybody?
Yes, sir.
Yeah. So let us see that what they are saying. So this is what the question they are giving. So imagine that the spring is came to the equilibrium. So equilibrium means definitely we all knows that there is an elongation in the spring. Am I right or wrong? All of you?
Yes.
So there is an elongation in the spring, M, but string is not. String is same. So 2M. So this is what equilibrium. So it attains the equilibrium position. So this is what they're asking. Now the question is find the acceleration after attaining the equilibrium position. If I will cut this, if I cut this with a scissor, clear everybody? Then what is the acceleration of this body and this body? So that is what we have to find it. Shall we find it now? All of you?
Yes, sir.
Okay. So for example, that is a secondary question. Let it be. Now first find what is the spring force, FSP in the spring. That is what is my question. So let us solve it. So imagine like normal case. So solution. So what is the first thing? Find the FSP, spring force. How much is the spring force? Shall we start now? Everybody? Yes. So let us start from the first. There is a second part. If I cut it, what is the acceleration? So there is a spring whose mass, how much mass is kept there? M mass, and there is a spring, and again 2M mass is kept. Now again, just imagine like a spring and tension, and you tell me. So the weight of this one is acting downward direction. So what is the weight of this one? Everybody? 2mg. Am I right or wrong? And this is the same spring, so that the same string tension is same, and here also same string tension is same or different?
Same.
Tension is same. Am I right or wrong? All of you? Nobody will say. Next, here again weight is acting downward direction. Am I right or wrong, Rudreshwar? Pradosh, understand?
Yes, sir.
Yeah. Now can you tell me the tension in the spring is equals to how much it is? T is equals to 2mg. Here also T is equals to 2mg. Am I right, everybody? Because these both are equal. Am I right?
Yes,
Yes. All of you. So there is a body. So tension is T and this is 2mg. So that we all knows that what is the T is equals to 2mg. Just now we studied. Am I right or wrong? T equals mg. Same thing. Okay. Now forget about this body. Only consider this body. Now, as we know this, the weight of the body is acting downwards, mg. Then upward something is acting in the spring. What is that? FSP. Am I right or wrong? Yes, spring force.
Yes, sir.
Spring force is equals to what? Just imagine that there is a mass m, and here is the spring is attached, and down is two forces are acting. One is mg and another one is t. T is equals to 2mg. So then spring force upward direction. So spring force is equals to these two forces. What is that? mg plus t. Am I right or wrong?
Yes, sir.
So mg plus t. So t is equals to what? mg plus
3 mg.
equals to 2mg. So that what is the spring force totally? What is the
3
spring
mg.
force, everyone? 3mg. Do you all able to understand it or not? Laksha?
Yes, sir.
Vishali? Pradosh? That is what. So very, very important.
Yes, sir.
If you understand this concept, this is easiest one. If not, it will be very, very tough. So do you all understand how to find the spring force? All of you? Clear?
Yes, sir.
Same string, same tension, same spring, same spring force. That's all. So I found it now. The spring force FSP is equals to 3mg. Okay. Now the question is at equilibrium string. Observe, make it everybody at equilibrium. At equilibrium. String also. Spring will study tomorrow. String alone we'll see now. So string is cut away. String is cut away. So who is that? String means first one or this one or this one? Which one? This one. Am I right or wrong, everybody? Yes or no, guys? So now when it is in equilibrium position, so I cut the spring. I cut the string actually. So this is the string. I cut it. Then the question is find the acceleration of both the blocks just after cutting the string. So as we all knows that this body will go down and this body will go up or down. This body will go up or down. Spring. This M body will goes up or not? If I cut the spring, if I cut the string, this M body will go up or down, everybody.
Up.
This, see, this body will come down. We all knows that. Then this body, what will happen? It is a spring, guys. It is stretched. So that
Sir, it
as
will
soon
go
as
up.
it cut the weight, it will go upward or downward? It will go upward. Am I right or wrong? It will come downward. So if I cut this string, when it is in equilibrium, so it is in stretched case. So elongation case. So as we know, definitely this M body will go up and this 2M body will come down. Is it right or wrong? All of you?
Yes,
Yes.
sir.
Yes,
That
sir.
is what. So at equilibrium string is cut away. Find at equilibrium. String is cut away. Find acceleration of both the blocks just after cutting the split, after cutting the string. Is it okay, everybody? Shall we proceed?
Yes.
Yeah, that's all. So just now, imagine that I cut the string, so that we all knows that what M body I'll consider. So M body upward is acting something, FSB, spring force. Now downwards, keep it in mind, as soon as, write in our notebook, as soon as string is cut, tension in the string will become how much? Fastly, everybody. Tension in the spring
Zero.
become, please respond, 0. So that only one force is acting downwards. What is that? Weight of the body. What is the weight of the body?
mg.
mg. And this body will goes upward direction or downward direction?
Upward.
Upward direction. So we all know that FSP equals to, what is that spring force? We already found it. How much it is? 3 mg. Then you can write the equation. So what will happen? 3 mg, this is upward. So that positive acceleration is up and this is negative. So 3 mg minus mg, which is equals to ma. So that 2 mg is equals to how much? 2 mg is equals to ma. Mm will get cancelled. So a is equals to 2g. So the body will go with what acceleration? Upward direction. What acceleration?
2G.
So upward direction or downward direction? Upward direction. Clear?
Upward.
Then this body will come downwards. So what is that body? 2m body. So as we know, upward tension is there, but tension, what will happen? As soon as if we cut, tension will become what?
0.
0. Okay. So down only one is acting. That is what? 2 mg. So that's all. So what will happen? 2 mg. See, if I cut this means it is indicating what? It is in a what case? Like a lift
Free fall.
problem. It is in a free fall. Okay, wow. So free fall means you'll travel with always what? You'll travel with only acceleration. Am I right or wrong? Yes, acceleration due to gravity.
Yes.
That's all. So 2 mg, F net is equals to ma. So F net means only this force. So that is what 2 mg is equals to ma means 2 ma. So 2m will get cancelled. A is equals to what, everybody? A is equals to G. So it is indicating that free fall and body is traveling downward direction or upward direction?
Downward.
Body is traveling downward direction. That is what you have to understand. Do you all understand how to solve it, everybody? Yes.
Yes, sir.
That is. So very, very important. So unless you show him interest, you people cannot able to solve these questions. Okay. Now for your understanding, one question with the solution I will send you. So you try to understand that question. If you not understand, then tomorrow I will teach you. Now only you are studying what? String cut. Okay. At the equilibrium, we are cutting the string or spring or string. Okay. Then tomorrow we cut the spring. Keep it in mind. Now I am saying the statement. If you cut the string, there is no change in the spring force. Clear, Mr. Udreswar? If you cut
Yes,
the
sir.
string, there is no change in the spring force. But if you cut the spring, there is a change in the tension. Do you understand what I am saying, Pradosh? If you cut the spring, definitely there is a change in the tension in the string. But if you cut the string, there is no change in the spring force. Is it okay, everybody? Yes. So that is what. So for that purpose, I will teach you tomorrow when you cut the spring, what will happen. But now I will send you the one question, which we are cutting actually the string actually. So try to solve that and find the acceleration in every case. So if you want to find the acceleration, first you have to find what? You have to find the spring force in every case. Okay. So spring force, you have to find it, and then you have to find the acceleration. Okay, guys, everybody, do you all understand? So this is what about the today's class. I hope you all understanding. So anybody doubt, anybody, you can ask me, or else you can leave from the meeting. I'll send the question, solve it, and then you sleep it. Okay. Thank you.
Thank you, sir.